So this is just a recap on rates of reaction and then looking at exothermic and endothermic reactions. So just to quickly recap on a couple of things that comes with rates of reaction, which is a core chemistry topic. What is activation energy? The minimum amount of energy required for a reaction to take place. What criteria must be met for chemical reactions to take place? Particles must collide with enough energy. So I've drawn a reaction here. You've got something you want to react, you've got the particles that are reacting with it, and they're all colliding into it constantly, but it's only when they collide with enough energy does a reaction take place. Now, there are a couple of ways that you can speed up the rate of reaction. So these ones are the ones that speed up the rate of reaction most commonly known. So temperature, if you higher the temperature or increase the temperature, particles will have more energy, so they're more likely to collide. These collisions then lead to successful collisions with more energy. You could increase the surface area, which is shown here in this picture. So that's a small surface area. That's a larger surface area. Larger surface area means more chance of successful collisions. Concentration, again, if you higher the concentration, there are more particles. So again, there'll be more particles in the same area, which increases the chance of collision. Pressure, again, pressure makes the area smaller, so pushes them into a smaller volume. Again, if you're closer together, you are more likely to collide. Now, another way that you can speed up the rate of reaction, which is more expensive, but is used quite often in industry, is to use a catalyst. Catalysts affect the rate of reaction because they lower activation energy without being used up themselves. So they lower that energy required for the reaction to take place. As I said before, particles are constantly colliding. It's only when they collide with enough energy does that reaction take place. So catalysts lower the energy required for a reaction to take place. Now, catalysts, and you need to know, come with some advantages and some disadvantages. They increase the rate of reaction and they save money because you're not using as much energy. You're not increasing the temperature as much for the reaction to take place. However, they're very expensive to buy. And even though they aren't used up, they need to be removed and cleaned. Moving on to the second part of this topic, that's just an overview or a quick recap on rates of reaction, is to look at exothermic and endothermic reactions. So exothermic, heat exits into the environment, into the surroundings, and then endothermic, heat enters. This can then be drawn in like energy profile diagrams. So it asks you to label them and work out which one it is. So this one is exothermic reaction, more energy required to make the bonds than to break the bonds. And then this one is an endothermic reaction, more energy required to break the bonds than to make the bonds. And then finally, you might be asked to calculate some bond energy information. So you've got your reactants and your products, and you've been given the amount of energy required to break the bonds. So I've added them all up here together. So it's 6, 7, 8 is required to break the bonds, and then you've got 8, 6, 2 is required to make these new bonds. The equation you need is reactants minus products, which I've done here, and that equals minus 184, which is then an exothermic reaction.